Next, I want to talk about something that is related to partial pressures, but this is a fraction. Instead of adding, we're going to be using fractions. And so what kind of fractions? Oh, how about something that relates to the mole? So think about the mole fraction as the number of moles of the compound you're interested in divided by the number of moles of all components. And so what this lets you do is it lets you relate pretty much anything in the ideal gas law as a fraction, kind of like a percentage or a piece of a pie. And so by doing this, you can solve for all kinds of variables. So if you know the pressure of one compound and you know the total pressure, you can solve for the mole fraction. And once you know the mole fraction, you can apply that for any parameter we're interested in. Because if I know my partial pressure and I know my total pressure, and I know my total volume, I can use this mole fraction as a way to get to my partial volume. It just really depends on what it is that you're looking for. And so think about anytime you have a mole fraction problem, it's simply part over whole. You can apply it to whatever. It's called mole fraction, but it could be pressure fraction, okay? And so the idea here is that you have part over whole, and then you can compare that to your ideal gas law. So let's do some practice. The partial pressure of 3 gases in a sample of gas were found to be these pressures respectively. So calculate the mole fraction of oxygen. And notice you don't have to change the units if you don't want to atmospheres, because we may or may not be using the ideal gas law. If you don't use the ideal gas law, then you don't need to change it. So we want to calculate the mole fraction. And which mole fraction equation does it make sense to use? Look here, we're given 3 pressures. Do we have any moles? No. Do we have any volumes? No. Do we have any temperatures? No. So just use that last one over here, this one. The mole fraction equals the pressure of the substance divided by the total pressure. Let's give it a try. So we have mole fraction equals the partial. Which one are we looking for? So this one goes here. Respectfully just means whichever one's listed first is first. Whichever one's listed second is second. And whichever one's listed third is third. So the mole fraction of oxygen says 563 goes on top, and then you put the total on the bottom. So what's my total? 143 plus 469 plus 563 millimeters of mercury. And if you do that math, you get a mole fraction of oxygen equal to 0.479. And I heard that voice inside each of your heads saying, wow, that was easy. Can we make the entire exam be made up of problems like this? No, we can't, but this is a very useful tool. The problem with this question, and I'll warn you now, we don't do too much with it, but it's still an important concept. Half of you are going to forget it and miss it on the exam. I don't want you to miss it. So maybe now just remind yourself, mole fraction. If you're asked for something that's a fraction, fraction is a part over a whole. Don't miss it. You can do it. I got faith in you. All right, let's do another one. So try this one on your own. The mole fraction of nitrogen in air is 0.7807. Calculate the partial pressure of nitrogen when the total pressure is 725 torr. So try this one. So first, write down the equation you think you're going to use. Mole fraction of nitrogen equals partial pressure of nitrogen over total pressure. And now what do we know? What variables do we know? Try it now before I get started, and then turn it back on and let's do it together. So your mole fraction is known, 0.7807, no units, that tells you it's a mole fraction. Then we're trying to solve for the partial pressure of nitrogen, and then total we have 725 torr. Since torr is my units, those are going to be my units that I report in the end. And so my partial pressure of my nitrogen is 566 torr. And that's my final answer.